one thing I kind of want to talk about is, okay, unlike quadratic formula and those kind of things, where A, B, and C are clearly defined, in this situation, it's sort of unclear, okay, how do you know which one is U and which one is V dash? It can't be as simple as, oh, well, it's whatever order they give you. In fact, it does matter which one you choose for the sake of complexity, rather than one is correct. Okay.
It's pretty simple if you use the order they've given you, because
yeah, why is that?
V dash is, that would be the derivative of e to the x, which is just e to the x.
Mm-hmm. Let's try it.
Okay.
So, x e to the x dx. Okay, so this is our situation, and our question was, okay, which one do we choose as which? Well, you're saying, let's keep the order. Let's see what happens. So you've got u is equal to x, u dash would be equal to 1, v dash equals to e to the x, well, v still equal to the e to the x there. I sort of lay it out like profile, but just be aware that, you know, in this situation, you've got v dash and v rather than the other way around there, okay? So that's our situation. What's our formula saying? Well, our formula is saying here, then my integral x e to the x would be equal to, well, what's my VU in this situation? It's x e to the x, cool.
I see.
So what happens?
Hold on. If I'd picked, hold on, I've got to actually see, but I think you might just be left with, in that second integral thing, you might just be left with something just as complicated.
Okay, right.
What you started with. I'm not sure if that's what I've done though. I can't tell. Hold on. V u dash.
So what's VU dash?
I have done the right one.
Ah, good. So 1 times e to the x is just
e to the x.
good. That's quite nice, isn't it?
Yeah. Okay. So that's why it matters.
Which is just e to the x plus c. Okay, that's all well and good, and that's correct actually. I guess the question is, what would have changed if we hadn't chosen it in that way? Well, we can find out. Or let's have a look. So we get the integral of x e to the x, but this time, let's suppose we swap these around, and let's say I chose u as e to the x, and u dash is just as easily found. It's still e to the x. V dash is x. V would just be half x squared, okay? And so if we look at this situation here, right? Okay, so what's uv? That's all well and good, half x squared e to the x. But then, what's my vu dash in this situation?
VU dash half of x squared times e to the
Right, which, as you realized, exactly, which doesn't get you anywhere. So therein lies our sort of dilemma. How do we choose something such that we don't end up with this problem in the first place? Is it a matter of trial and error? Is it a matter of the order they give you? Okay, just as a hint, it's none of those. But what I want to suggest is that, let me give you another example. Let's try this one. What I want to suggest to you is this, right? The trick in it, and I think you sort of realize, is that when you find this expression here, you want this expression to be easily integratable. Whereas this one, it wasn't. Okay, so where does that sort of come into play? It comes into play with this situation here, right? Basically, the idea is this. We want the u dash to be integratable, very easily integratable.
ln x is pretty easy to integrate. Wait, so...
That's another tip as well, actually. So another tip is, when you pick v dash, it actually needs to be integratable fairly easily. In this situation, both of these were integratable, so that wasn't much of a clue. But if you start combining these, you'll already realize, what is the integral of ln of x?
It's 1 on x, and therefore...
Well, here's the thing.
It's a, oh, hold on, did I get that? Did I just get that confused with something else? Was I just... Hold on. Or is is that the derivative?
Which way is it? How do we know?
Hold on.
Which one's the correct one?
Oh, the second one is correct.
Yeah, the way I think about it is like, if you integrate this using your normal rules, it doesn't work.
Yeah.
That's why it has to be a special result. That's why it's a lot.
Well, I just remembered that you've got absolute value on the ln of x.
Yes.
And we've only started doing that in integration.
Yeah. Go away. Okay, so that's not the right one, right?
Yeah.
So, and I guess, honestly, you can also check by taking the derivative of this as well and realizing that that's not that. So that's another way you could think about it, right? So, you can't integrate ln of x easily, at least. That's one sort of clue. But another sort of clue is, remember, we said that we want the u dash to be nice and easy to integrate. And what happens, right, when you pick u as ln of x? Well, if I pick u as ln of x, what does u dash become? What's our derivative of ln of x?
We've done this, and I can't remember what it is.
Which way it goes?
No, I just can't remember what the integral is. No, wait, the derivative
Yeah.
of 1 on x.
Yeah, okay. Not a trick question in this
Okay,
situation.
that's what I meant.
Yeah.
That's what I was thinking.
Okay.
Because then you've got that times
Good.
by x cubed, which you can easily get the integral.
Yes, good.
So
Okay.
my mind had the right idea.
You just weren't expressing it correctly, at least. Okay, so that's all well and good, right? So you can start to see sort of a picture forming about which functions you want to choose. The way I think about it, because I don't want to sort of confuse you with options, so you want to consider everything there. But the way I think about it is, how do I pick u? Right? I want to pick the variable u. And in general, right, when you pick something like a log, it's going to be much more easy to integrate rather than trying to work with integrating logs, okay? So it's easier to differentiate a log than to integrate it. And also a side benefit is that in this situation here, it makes the expression simpler, right? That's one sort of clue there at least. All right, let's keep going. So we've got my integral now. X cubed ln of x dx is equal to,
So it's b times u, so
yeah,
x to the power of 4 on 4 times ln of x. I don't know what way you want to write it.
that's fine. Whatever way you find appropriate.
Okay. ln of x plus the integral of, oh wait, minus.
Yeah, good.
Okay, that's gonna trip me up. Minus the integral of vu dash.
Yeah, and you can see actually what happens here, right? What happens over here.
Well, yeah, copy the x sort of cancel.
Boom, boom, go away. X to the 4 on 4, ln of x, take away integral of x cubed on 4, or I can take out the quarter. And then we have our constant here. When we integrate x cubes, this becomes x to the 4 on 4. Should probably put a cube there. So that's integration by parts, right? We can actually think about, I've got a product of two functions. How can I integrate them easily? Okay, it's still a bit unclear though. Like how do we know what to pick when? Is it just a matter of gut feeling? Is it a matter of, I mean, you just see it and you know?
Just quickly b and u dash would be.
Yeah. And see which one's easier, kind of.
Yeah.
Let me give you another one to try. Have a look at this one. You tell me which one you think's easier.